We are going to now do the continuity question. So we are moving on to question 3, and I'm just going to go write it on the side here. What was it? 1 over x plus 4. I've already forgotten. X squared minus 1. Sure, Kiana, I will. I'll try to do it today. Okay, so this is our question. I'm just going to go look at it up here briefly. So we have f of x is equal to this function. It says to find the values of x where it is not continuous and justify your answers. So in order to justify our answers, what that means is we need to use the limit definition of continuity. Does anyone remember? Tell me in the chat, what is the limit definition of continuity? If f of x is continuous at c, at x equals c, if what? What has to be true for a function to be continuous? And you guys had to like write this on the midterm, I'm pretty sure. You got it. So this is our limit definition of continuity. It should definitely contain limits. Good job, guys. You got it, Ellie. It's good. All right, exactly. So good job, guys. Yes, there we go. So we're saying if the left-handed limit, so c from the left of my function, is equal to the right-handed limit, so in other words, the limit exists, and it has to equal to the function itself evaluated there. And they all exist. So this definition is important, and just FYI, sometimes you're specifically asked to state it on the final, so you may end up having to state this. But regardless of whether or not you have to state it, you have to use it to justify your answers. This is the only justification that's acceptable. So remember that with continuity questions, we have 2 steps. Our first step is to find any possible division by 0. So we'll do step 1 here. And for step 1, we always start by looking at each function separately. So I'm going to start with x plus 4. What value might cause division by 0 here?
X equals minus 4.
You got it. X equals to minus 4. So I have 1 over x plus 4. X plus 4 equals 0 when x is equal to minus 4. And so then we ask ourselves, is that minus 4 important? In other words, is it on the interval in question? So I'm like, is negative 4 less than or equal to 1 question mark?
Yeah.
Yes. Okay, so what that tells me is that x equals -4 is definitely a discontinuity, but this is not justification of that answer. This is just like saying, hey, look, it's not there. It's not in the domain. It's not justification though, because it's not using that limit definition. It also doesn't state the type. So what should I do next to be able to state the type and justify?
You do the limit as x approaches -4?
Exactly. So I don't just plug in -4. That's kind of what I did right there. I look at this limit definition. I need limits. So I'm going to be doing then the limit as x approaches -4 of my function. And that brings me to the first interval. And when I plug in, I get 1/0. And what does 1/0 mean?
It's either like infinity minus infinity does not exist.
You got it. So tell me in the chat. Yeah, good job, guys. What kind of discontinuity do I have?
In the chat?
Yeah, tell me in the chat.
My bad.
It's okay. Yeah, you got it. So then our conclusion is that x equals -4 is an infinite discontinuity. And that is my final answer here. So then I'm going to move on to my next function, x² - 1 over x² + 8x - 9. So then I'm setting x² + 8x - 9 equal to 0. And remember, does it make sense for me to bring 9 to the right side to solve this?
No.
No. What do I do instead?
Quadratic.
Or yeah. Well, first, wouldn't you like factor? And if it can be factored, then you do quadratic.
Yeah, so if you can factor it, exactly, great, factor it. But if you have trouble with that, you can always just use the quadratic formula as well. So whatever you're more comfortable with, although I do recommend at least trying to factor it first, because oftentimes you will make less mistakes and it's just faster. So in this case, I have x + 9 times x - 1. Why? Because 9 times -1, good job, Gabriel, is -9. 9 minus 1 is +8. So this gives me x is equal to -9 and x is equal to +1. So now I want to check both of those. So I'm going to check -9. 1 is less than -9 is less than or equal to 2, question mark. Is that true?
No.
Nope, not on the interval. No. And then we're going to check 1. So here I'll have 1 is less than 1 is less than or equal to 2. Is that true?
No.
Also, no, because this interval is not including 1. Okay, so then we move on. We don't have anything to think about there, so we move on to the next one. So then I'm looking at 3 over x² + 4. Do I have division by 0 here?
Yeah. Plus or minus 2?
You sure?
Yeah.
Well, no, because then it's you can't do square root
Oh,
of
you can do.
-4.
Yeah, right.
You got it. So this would give me x² is equal to -4, and that negative is the thing that stops that from being true. So if this were x² - 4, then we'd be okay. But so the answer here is that this never happens. So I am officially done with step 1. How many discontinuities did I find in step 1?
1.
1.
1. What's my step 2?
Label like the left and rights of each x value.
Yeah, let's go do that. Okay, so here, what are my breakpoints?
1 and 2.
You got it. So my breakpoints are 1 and 2. Okay, tell me in the chat, function 1, 2, or 3, where should I go for 1 from the right? One from the right, guys. So 1 from the right is this. Where should I go for 1 from the right? Okay, so most of you are getting it. Remember, 1 from the right would be like 1.1. 1.1 is at that middle equation. So here we're going to write 1 from the right. Where should I go for 2 from the right? 1, 2, or 3? First, second, or third? So now I want 2 from the right.
Third. Third.
All right, good job. So that's like 2.1. Good job, guys. That's the third. So then 1 from the left is up here, and 2 from the left is here. All right. Okay, so now we don't just plug those values in. We're looking at all 3 of the things that show up in this limit definition. I need to see if they all equal to each other. So I'm going to start with my first breakpoint. So we're at step 2 here. And my first breakpoint is 1. So I'm going to be looking at the limit as x approaches 1 from the left of the function, the limit as x approaches 1 from the right of the function, and f of the function. So I'm looking at all 3 things. And I want to point out that this is actually an important part of the justification. If you don't do the limit from the left and right, then I'll never know that you know which function goes with the left and which function goes with the right. And that's one of the things that's being graded in this problem. So the notation is actually really important because it gives me information about what you actually understand. So 1 from the left, we said we go to 1 over x plus 4. So now I replace f of x with 1 over x plus 4. And when I plug in, I get 1/5. 1 from the right, we said, is the second function. What happens when I plug in here?
Get 0 over 0.
Does that mean I stop?
No.
You try to factor.
No, you got it, I factor. So here I get 0 over 0. That doesn't mean I'm done. It doesn't mean there's a discontinuity. This is just the limit. We'll have to think about f of 1 later. So then I'm going to do the limit as x approaches 1 from the right. Here I have a difference of squares. And then down here, we actually already factored this. So we said it's x plus 9 times x minus 1. And then we cancel. And we plug in. And we get 2 over 10, which is 1 over 5. Now, which function do I go to for f of 1 itself?
The one on the left, like limit x approaches -1. 1 minus, sorry.
You got it, exactly. So I'm going to the first function, that 1 over x plus 4, because that's less than or equal. So then I'm like, this is 1 over 1 plus 4. Okay, privately in the chat, tell me what this means. What do my answers mean? All right, good job, guys. So some of you said that it's continuous. Some of you said that it's not discontinuous. Both of those are the same thing. The limit is the same as the function. The expectation, remember how we talked about limits? The expectation is equal to the reality. So here I could say that f of x is continuous at x is equal to 1. So it's not one of the discontinuities, but we did still have to check it. Now we're going to check x equals 2. And so we'll start with the limit as x approaches 2 from the left of the function, the limit as x approaches 2 from the right of the function, and f of 2. And 2 from the left was our middle function. So we replace it, and then we plug in, and we no longer write our limit sign. So I get 4 minus 1 over 4 plus 16 minus 9. And now pay attention. Remember, we write the limit sign when we're not plugging in. When we plug in, we no longer write the limit sign. The limit sign disappeared. We're evaluating the limit when we plug in, so the sign is not there. Okay, so then 3 over x squared plus 4 is our third function. So I replace f of x and then I plug in. So I end up with 3 over 4 plus 4. Do I need to go on and evaluate f of 2 at this point?
Yeah.
Or can I make my conclusion without evaluating f of 2?
No, you need to, because can do it. Yeah, you need to. Could it be like a jump discontinuity? No.
Yeah, so I'm actually done. So I don't need to evaluate f of 2 because the limit definition up here already broke. Already my left and right hand sides aren't equal. And because they are not equal, I can conclude that this is a jump discontinuity.
If the f of x, like if the reality does not exist, but the limits were real, then you like.
Okay.
How could you know that f of 2 is not like DNE, right?
Okay, it could be DNE. And I'll draw you a graph of what that would look like. So let's say that f of 2 is DNE. Then what that would mean is I have on the left side going to one point, and from the right side going to another. And so there would just be no closed dot at either one of those things. And I would still have a jump discontinuity. So the thing is, infinity cannot happen at f of 2. Right? Maybe it doesn't exist, but if it doesn't exist because there's an asymptote, then one of those limits will be infinite. So the fact that neither of those limits is infinite tells me that there's definitely not an asymptote, which means if f of 2 doesn't exist, it's just something like this that's happening. Does that make sense? Okay, if however you're more comfortable going and evaluating it just to be safe, absolutely you're allowed to. F of 2, we go to the middle function. So f of 2 is 2 squared minus 1 over 4 plus 16 minus 9 is equal to 3 over 11. Well, I did this backwards, but yeah. And not necessary because we were already able to conclude it was a jump. So x equals 2 is a jump discontinuity. So I just want to go back again and talk about why it's not necessary. So like, as I was saying, if you have a graph like this, right, and on the left side you have it coming here, and on the right side you have it coming here, the possibilities for what f of 2 could be does not exist, and then it would just look like this. It could equal to the left-hand side, then we still have a jump. It could equal to the right-hand side, then we still have a jump. Or it could just be a random other point. Do I still have a jump? Yes. Now, the reason that in this case right up here, with x equals 1, I still had to evaluate, even though I got that the left and right limits were the same, is because I have it going in to the same thing on both sides. So here my possibilities for that value does not exist, and then it looks like this. And if it looks like this, what kind of discontinuity do we have?
Removable.
Removable. Or it could be something like this. What kind of discontinuity do I have?
Jump. No,
Still
that's
removable.
Okay.
Still removable. But what if I had something like this? Now what's going on?
There's no discontinuity.
There's no discontinuity, right? So when we had both of the limits were the same, we had this possibility that f of 2 was going to, or in this case, f of 1 was going to fill in that hole. So we needed to check to see if it happened. Over here, it's like, no matter what happens, the left and right are still different. Does that make sense? Are there any questions about that? Okay, I'm going to erase these graphs if that's okay. Are there questions about this continuity question? Okay, then we're going to move on to question 4. Okay. Sorry. Okay, so question 4. We want to find all the values of k for which the function f is continuous on R. So we want this to be continuous everywhere. So we're still going to follow the same steps that we followed. We have our step 1, and we have our step 2. In my step 1, is there any possible division by 0?
No.
No. So there's no possible division by 0. And what that means in this case is that there isn't a step 3. So if you guys remember with these problems, we actually had a third step that was to check to make sure that your k values don't cause a discontinuity. We don't have to check that in this case because there's no possible division by 0. So in other words, there's no step 3. And if you guys want, we can go back and talk about that after we are done. So no step 3. Okay, so that means we move on to step 2. And in this question, we're also going to want to justify our answer using that limit definition of continuity. That's the only justification that's acceptable, which means here I'm doing the same step 2 I was doing above. I need to show all of my limits and the function. What's my breakpoint?
2.
So I'm doing the limit as x goes to 2 from the left. The limit as x goes to 2 from the right. And f of 2. So I want you guys to take a second, tell me in the chat privately, do I go to function 1, the top function, or the bottom function, top or bottom, for 2 from the left? Hang on, my mouse is just like not allowing me to see the chat. Come on. There we go. Okay, so there are a lot of people here. I just want to remind you guys that today, your class participation grade is based on answering questions, and I'm only hearing from like the same 10 people when there are technically 20 people here. So just keep that in mind. Okay, so good job, guys. We're going to the top function. So that means I still write my limit sign, and I have my top function. Okay, so am I plugging that 2 into x or into k?
The x.
Okay. Sorry. So this means I have 2k squared plus 6. And then I have the second function. And again, I'm still plugging in to x. Which one should I go to for f of 2?
Well, the one on the first one.
So I have that line under the less than with the first function. Good job. So we're going to the top function. So here, this is just 2k squared plus 6. And now, as part of my step 2 here, or rather now I want to set all of these things equal to each other. These are already the same, so I just need to set them equal to 2 times 9 minus k. So I have 2k squared plus 6 is equal to 2 times 9 minus k. Okay, and then I want to solve this thing. So again, this k squared right here, the fact that I have the k squared term and the k term means that I need to get them all to one side equal to 0 and factor. So first I'm going to distribute that 2. So I have 2k squared plus 6 is equal to 18 minus 2k. So then I'll get 2k squared plus 2k plus 6 minus 18 is equal to 0. Minus 12 equals 0. And the first step of factoring, the first thing that you should always think about, which many of you have noticed have been getting much better at that this semester, is thinking of the greatest common factor. I noticed also that many of you just ignored greatest common factors on your practice test, your mock test, and did really poorly because of that. So always be on the lookout for the greatest common factor. And yes, you always need to do step 1. Sometimes it's important. In this question, it ended up not being important, but you should always think about it. So here my greatest common factor is 2. So I'm going to factor that out. So I have 2 times k squared plus k minus 6 is equal to 0. So I want 2 numbers. Tell me in the chat what they are. Multiply to give me -6, add to give me +1. Good job, guys. 3 and negative 2. So this is 2, k plus 3, k minus 2 is equal to 0. So then I get k is equal to negative 3, and k is equal to positive 2. And then I'm just going to write this so that we can remember it. My answer is 3 and negative 2, or negative 3 and positive 2 by mud. So my step 3 here is we don't need to go back and check if those k's potentially cause division by 0 because there was no possible division by 0 in step 1.
So our answer would be f of x is continuous when k is equal to minus 3 or 2.
You got it.
Okay.
Okay, what possible thing could have happened? What denominator could I have had? Tell me in the chat if you can think about it. What denominator could I have had that would have caused me to have to do step 3? There are lots of different answers to this question. I want you to think back to the ones that we did in class. No. Okay, so I'm getting a lot of like k plus 3 and k minus 2 as answers. And those are possible. So k plus 3, k minus 2. Another thing that we did in class was x plus k or x minus k. And so this is another thing that you're gonna have to look at. So like if you have something like this appear, this is actually pretty straightforward to see. You can be like, oh, I got negative 3. Of course, now I have an infinite discontinuity. But x plus k and x minus k is the thing that makes this problem a lot more challenging. Okay. Are there any questions about continuity? All right, then. So that was our continuity question. Our 2 continuity questions. We remembered the limit definition, and remember, notice we really used that limit definition each time. The GCF was 2, Alex. Yeah, so like, let's say, for example, Kiana, that we had something like this. Let's say that I had 3 over x plus k for x less than 2, less than or equal to 2. Okay, then in step 1, I would have gotten x plus k is equal to 0 when x is equal to negative k. Okay, and then if I'd gotten the same negative 3 and 2, so I have k is equal to negative 3, k is equal to 2. There are 2 main ways that I can do this, and I think I did them in, I think Ethan actually taught you this. Did Ethan teach you this? Ethan taught you this.
Yeah, I think we had a course with him about like doing the k discontinuities. So,
Yeah.
I think it was.
And then in the, I had you guys watch the solutions video for one of your group works where it happened as well. So what we would do now is we really have 2 options. I got that there's a discontinuity when x is equal to k, and then remember the interval here is x less than or equal to 2. So here I would say negative k is equal to positive 3, and then I would check 3 less than or equal to 2. No. And then the other thing would be negative k is equal to negative 2. Is negative 2 less than or equal to 2? Yes. Which would mean that that 2 causes a discontinuity. So k equals 2 causes a discontinuity. So that's one option for how you could deal with it. The other option would be to just plug in the k. So you could be like, okay, so now I have 3 over x minus 3 when x is less than or equal to 2. And this is when k was equal to minus 3. And when k is equal to 2, we would have 3 over x plus 2 when x is less than or equal to 2. And redo step 1. Do you guys remember doing this? Is it bringing back pleasant memories? So this is our option 2, and this is our option 1. Okay, are there any other questions about this? If you are struggling with this and you want me to do a problem tomorrow where this happens, I'm happy to, but just FYI, this did show up on a group work and there is a video of that group work solutions that you could also go look at, like try to do the question from the group work and then look at the solutions. All right. Moving on. Why does this keep happening? So we are now moving on to derivatives. Are you guys ready to do some derivatives? So with derivatives, I want to remind you that your final is on everything from the whole semester, but there's definitely a bigger focus on what came after the midterm. And on the midterm, you had derivatives, but you did not have derivatives that involved trig. So what that means is you can expect the derivatives on your final to involve a lot of trig, to be more trig-based because you already covered everything. So if you have not memorized all of your trig stuff and you have the same reaction that Luca just had, then you might should get into like studying those trig derivatives. So with that said, I want you guys to look at A, B, C, D, and E and tell me privately in the chat which ones require implicit differentiation.
Wait, what? Look at what?
6, A, B, C, D, and E. So the derivatives that we have here.
Okay,
Do any of them require implicit differentiation? If so, in the chat, tell me which ones. Implicit. So either say no, because no implicit is required, or tell me which ones. And guys, I'm guessing that a lot of you are getting confused about logarithmic and implicit here.
Yeah.
So I'm asking about implicit, not logarithmic. Tyler? What? You're here and you're alive? Yay! A, B, C, D, E, do any of them require implicit? Okay, so I've gotten good answers from most of you. The answer is that actually, no, none of them require implicit. So now, do any of them require logarithmic differentiation? If so, tell me which ones. You were going to be right, Alex. So now you should be thinking about logarithmic. And I only want the ones that require logarithmic. Okay, so this one's a little more challenging for you guys. I'm getting a lot of B. And remember when logarithmic is required, it's because I have a function, so I have x's down here, and in the power of my x's, I also have some x's. So in D, notice I have this 2 down here, and the power of my 2 is x's. And then this 3x is in a totally different place. So there are no x's in the base that also have x's in the powers. Whereas down here for E, do I have x's in the base and x's in the powers? Yes, good job. So here, logarithmic differentiation is going to be necessary. And this is really important because a lot of you got like 0 points for this question on your practice test, on your mock test, because you didn't use logarithmic differentiation. So that said, logarithmic differentiation is actually not useful for any of these. We have to use it on E, but for the rest of them, it's not going to be helpful because of all these plus signs. So like here, all of those plus signs make logarithmic differentiation pointless. Here in the denominator, that plus sign. Here, that plus sign. In C, you would just take one chain rule and turn it into another chain rule. It's not like I have any product rules or quotient rules here. It's just a couple of embedded chain rules. So logarithmic differentiation.
Even if we didn't have like pluses and we had times, like it wouldn't be needed. You could theoretically do it like.
So that's what I'm saying though. It's not useful for any of them really. Yeah, so like definitely you wouldn't have to do it, but it's also not useful for any of them. Like it's not going to help you to make them easier. Whereas if you look at 7, logarithmic differentiation will make this a much easier problem. You don't have to use it because again, there are no x's in the base and no x's in the power. There's just x's in bases with numbers as powers and numbers in bases with x's as powers. So here it's not necessary, but it's definitely going to be helpful. And my suggestion is when you get your final, you should do exactly what I just did. Look at the derivatives and say, is logarithmic differentiation necessary for any of these? And if so, write it down immediately so you don't, like, in the stress of the moment, forget to do it. Okay, you guys ready to do these derivatives? All right, so we're going to do 6a. I have 3 to the x plus the 5th root of x cubed plus cosecant x. Okay. So as usual, the first thing we want to do with derivatives is rewrite things in their simplified forms. So is there anything that I can rewrite here?
Yeah, the 5th root of x cubed.
You got it. Okay. Now this, I want you guys to tell me in the chat, what should the power of x be? So tell me privately in the chat, the 5th root of x cubed, how can I rewrite that as a power?
Wait, it says y is equal to all of this, which is equal to 3 to the power of x plus x.
Right, because I'm rewriting it right now. I just haven't finished.
Oh, okay.
Yeah, like I'm waiting for you guys to tell me what the power should be.
Okay, I was confused.
Yeah, I can see that. All right, good job. So I got this. I got a couple of this. Please don't do this. You're creating a chain rule for yourself that you do not need to create. So be very careful. While this is correct, don't do it. That 3 over 5. And then there's really nothing else I can simplify. So I'll have plus cosecant x minus 5 log base 3 of x plus e squared. And now we differentiate. And all of these are just simple known forms. I should know 3 to the x, that is 3 to the x. Is that all?
Ln 3.
Times ln 3, don't forget to multiply by ln of the base, plus I bring the 3 over 5 down, x to what's my new power?
Minus 2 over 5.
Minus 2 over 5. Plus, what's the derivative of cosecant? Tell me in the chat. The faster you tell me, the more I know that you know it. No. Still no. Got 2 wrong answers. Yes, there you go, David. Yes. No. Yes. Yes. So it is minus cosecant cotangent x. Is this right?
No, it's plus parentheses minus cosecant times cosecant x times cotangent x.
Yeah, so I can actually just change the plus parentheses to the minus. Oh, there you go. Okay. But that x right here needs to be there. So I noticed a lot of you on your practice tests forgetting that x. So that x needs to be there. So be careful about that. No, you do not have to simplify the negative. On the final and on your mock, like it should say, most of the time it will say, do not simplify your answers. So I noticed on the mock test, a lot of you guys simplifying your answers when it was not necessary and simplifying them wrong, simplifying them incorrectly. So you had a nice correct answer that I could have given you full credit for, and then you lost half a point because you incorrectly simplified when you didn't even need to simplify. So like, if you don't have to simplify, just don't. So if it says do not simplify, don't do it. The only time you want to simplify is if it specifically says simplify, or if you're trying to find critical values or horizontal tangent lines, you're setting the thing equal to 0. Okay, so then we'll keep going, minus 5 over x. And again, my base is 3, so I need that ln 3. We always do ln of the base. So ln 3, what's the derivative of e squared?
It is nothing.
It's nothing. It's 0. This is my final answer.
I just have a question for the negative exponent.
Yes.
If we would have written it without the negative exponent, would it be 3 over 5x to the power of 2/5?
You got it. It would look like
Okay.
this. Yes. Okay. Any other questions about this one? Then let's do B. So my y is equal to 2 to the 5x minus 7 over 3x plus cotangent 2x. What rule do I need here? The quotient rule. I have F and I have G. So in terms of F and G's, in the chat, guys, privately, tell me what the quotient rule is. Just because I've seen a lot of you messing it up recently. Yes, good job, Matt. Yes, good job, David. Yes, yes. All right, good job, guys. So it's f prime g minus fg prime over g squared. I've been seeing a lot of you forget the minus sign and do a plus sign instead. And I've been seeing a lot of you forgetting the divided by g squared, just not dividing by anything. So we're going to do this. I'm going to do it in 2 steps. Y prime therefore equals to the derivative of the top times the bottom minus the top times the derivative of the bottom. All divided by the bottom squared. And now I'll actually take my derivatives. I've just put the things that I have to differentiate in primes. Now I will do those primes. So I'll get that y prime is, bless you.
Sorry. Thank you.
So this is going to be 2 to the 5x plus 7. Don't forget to multiply by ln 2. Is there anything else I need to not forget to multiply by?
5.
5. We're doing a chain rule here. Times 5 times the bottom minus the top times the derivative of the bottom. Privately in the chat, what is the derivative of cotangent of 2x? Yes. Good job, David and Kiana. No. You guys definitely need to get on studying your trig. Yes, Matt, good. Almost. Almost. Yeah, there you go. Yes, Michael. Okay, so it's negative cosecant squared of 2x, and then we have to multiply by 2 because we have a chain rule. And that's my final answer. What was C?
If someone would have done the logarithmic differentiation on that for the top, like the one that we did B,
Yeah.
it would, like, of course he would get a different answer, but would it still be considered good or no?
Well, it depends because it's easy to screw this logarithmic differentiation up. I will do it right now real quick, just using logarithmic to show you how it would work.
Okay.
So if you use logarithmic, it's not really helpful. It doesn't change much at all. You would do ln y is equal to ln of the whole thing, 2 to the 5x plus 7 over 3x plus cotangent of 2x. Okay, and so then I would simplify and I would get, so I'll do this in black, ln y is equal to ln of the top minus ln of the bottom. Now there's nothing more that I can do to simplify the bottom because of the plus sign, but on the top I can bring that 5x plus 7 down. So I'd have ln y, 5x plus 7, ln 2 minus ln of the bottom And now I can differentiate. So when I differentiate, I'm going to get y prime over y is equal to the derivative of 5x plus 7 is 5 times the constant minus 3 minus cosecant squared of 2x times 2 over 3x plus cotangent of 2x. So I just did the derivative of the inside on top and put it on the bottom. So g prime over g, and then I multiply the y prime over. So my answer would look like this. And if you simplify this answer by distributing the original function, you'll see that it's actually the same thing. So if you do logarithmic differentiation and you do it like this and you do it correctly, then absolutely you'll get full credit. But notice it didn't really make my life any easier. It created a couple chain rules that I did in place of the quotient rule. Does that answer your question?
Yeah, thank you.
Okay, see? So I have a square root. As usual, when I have a square root, I want to start off by rewriting it. So I'm going to rewrite this, secant of x squared minus ln x, all to the power of 1/2. So what is my main rule that I'm going to start off with?
My power rule, the power rule.
The power rule. So that is like saying I have g to the 1/2. Now question, what word should I insert between the secant and the x squared minus ln x? Times or of?
Oh,
So can I separate that secant from the x squared minus ln x? They are stuck together. This is not a product rule. It's not some random secant times x squared minus ln x. It is just one giant composite function. So first I'm going to do this in multiple steps. So first I'm going to bring the 1/2 down. I don't touch what's inside. I subtract 1, and then I pull out the derivative of what's inside. And because this is secant of x squared minus ln x, this is like secant of g, which means that this is another chain rule. It's like my trig chain rule. What's the derivative of secant?
secant tangent, but you have to include the g in the inside for tangent as well.
Got it. You got it. So it's not secant x tangent x. Well, I mean, yes, it's secant x tangent x, but in this case, it's secant g tangent g. So that means I have secant of x squared minus ln x tangent of x squared minus ln x times the derivative of what's inside. So I pull the thing out. So it's like a fruit roll-up. We're always just pulling out, pulling out, pulling out. What's the derivative of x squared minus ln x?
2x minus 1 over x.
You got it. So I'm just going to replace that. And this is my final answer. All right, so this is our d. And again, logarithmic differentiation is not useful here because of that plus sign. Remember, ln of a plus b does not equal to ln a plus ln b. We cannot distribute that ln inside of a plus sign. So we're just going to go at this. So the first thing that we have here is like a g cubed. So here I'll have y prime is equal to 6 times 3 x e to the x plus 1 squared times x e to the x plus 1 prime plus, what's the derivative of x squared?
2x.
2x. Good. Now I have this prime. What rule do I need for this prime?
Product.
That's going to be a product rule. That's like an F. That's like a G. This is a product rule. So the derivative of the first times the second plus the first times the derivative of the second gives me x. It gives me e to the x plus x e to the x plus 2x. And that is my final answer.
Wait, was this on the exam?
Yeah.
Okay.
I just brought it up in a different place because it was making my headache worse going back and forth between them.
Yeah.
Okay, any questions about this one? All right, that brings us to our last one, E, and that's the one where we said logarithmic differentiation was necessary. Okay, so we said logarithmic differentiation is necessary here. That makes sense. Look, down here, this is my base, there are x's. Up here, this is my exponent, there are x's. So there are definitely x's to the power of x's. Uh-oh, hang on 2 seconds, guys.
Hello, Audrey Lynn Baker. Okay, bye.
All right, sorry about that, guys. Okay. Yes, I did. I had mail. All right, so we're going to do ln of both sides. And in this case, there's not a constant that we have to think about separating or not, but most of you guys messed that up on the mock test, so be careful when there is that constant That is a thing that we've talked about a lot. So maybe go look at the mock test, see if you did it right. And if you did not, think about why. So because there's not a constant, I can immediately bring this sin x down. And when I bring that sin x down, I am not doing a derivative rule. I am doing a log rule. My log rule being that ln of a to the power of b is equal to b ln a. All right, so I just brought that b, that sin x, down to the front. And then we've said when you're doing logarithmic differentiation because you have to, seriously? It's okay, Cam. When you're doing logarithmic differentiation because you have to, you will have a product rule, and you should always be on the lookout for that product rule. In the chat, what's the derivative of sine? Yes, so I have cosine x ln of ln x plus e to the 3x plus sine x, again in the chat, what's the derivative of my g there? This is going to be a little harder to type in. Not quite. It could be a typing in problem, but not quite. Michael, you're close, but it's still not quite. I want the derivative of the whole thing. Maureen, you're also close, but not quite. My g, guys, is ln of ln x plus e to the 3x. It's not just ln x plus e to the 3x, it's ln of that. Okay, I'm gonna wait for a couple more answers. There you go, Sam, good job. Okay, I'm gonna wait for one more person to answer. It was better before, Michael. Okay, so ln of g, remember, ln g prime is g prime over g. So what that means is the thing inside ln x plus e to the 3x goes in the denominator, and then in the numerator, I do the derivative of the things as I see them. And I recommend not simplifying because I've seen you guys try to simplify this by just bringing that x to the denominator, and it does not work that way. So be careful. If I had written, hang on, b ln a. If I had written here y prime over y, would that be okay?
No.
No, I haven't taken any derivatives yet. I just used a log rule. And so on your mock test, a lot of you did that. You just started writing y prime over y immediately. We don't write that until we start taking derivatives. So at this step, I hadn't taken a derivative yet. That is wrong. This is just still ln y. So now I'm going to multiply y over. Is it okay to leave my answer like this? Oh yeah, sorry, I forgot the times 3, my bad. Thank you, Maureen.
No, you have to replace y with the original value, so ln x.
Exactly. We don't want to leave y there like that. Writing y is not, you're not going to get full credit for that. We want to multiply by the original function. So this is ln x plus e to the 3x, all to the power of sine x. And this is my y prime. Okay, are there any questions about this? That is the derivatives. So we're going to do just one more question today. We are going to either do 7 or 8, and we'll do the one we don't do tomorrow. Do you guys have a preference as to which one you'd prefer to do in the end of class today? 7 or 8?
I prefer 8, but I don't really mind.
We'll wait for a couple other people to.
I agree. I think 8.
Yeah, there's a part of me, the reason, Kiana, that I'm not like 100% attached to going in order is because I feel like we just did logarithmic differentiation, and it might be useful to like separate that and do it again tomorrow. Because I think that you guys are still struggling with it, and that way you'll have it like 2 days. So why don't we do number 8? I've got a lot of people saying that. Also, want to just point out that this question we did not learn this semester. So if you're asked to find those super high derivatives, just ignore them. Right? Like those aren't going to be useful questions from the finals. Also, reminder, question 5 I'd crossed out here, not because we didn't learn it, but because it's not going to be on your finals. So we're going to do question 8, 2x plus 4 cubed, 3x minus 1 to the 4th. So you guys might remember that this question showed up as a really similar question on your midterm. So what is my like main rule that I'm going to start with here?
That the horizontal tangent lines happen when f prime of x is equal to 0? No.
Yeah, so horizontal tangents occur when f prime is equal to 0. So we know that f prime is equal to 0. So that means I need f prime. What rule am I going to start with f prime? Start with for f prime. Is it going to be a chain rule or a product rule, my first thing?
First thing is going to be product.
You got it. It's going to be that product rule first. Good job, guys. So this is f and this is g. So I'm just going to do this fast. So f prime of x is the derivative of the first times the second plus the first times the derivative of the second. And now remember, since we're setting f prime equal to 0, this means we need to simplify. And to simplify, that means I need my greatest common factor. And you guys are going to tell me privately in the chat, what is my greatest common factor here? So that's part of it, Sam, but not the whole thing. You got it, David. So Michael, think about what constants might be with it. So there shouldn't be any pluses or minuses in the greatest common factor. It's all multiplication. All right, good job, guys. Okay, all right, so that's good. A lot of you have it here. So first, remember, I'm gonna like separate this into like left side and right side of the plus sign. This 3, there is a 3 on both sides, so hands down, I'm gonna have a 3 in my greatest common factor. I'm pulling the 3 out. Then I'm looking at 2x plus 4 squared. There are 2x plus 4s on both sides. The smallest power is squared, so I bring the squared. Then I'm like 2. I have a 2 over here on this side because 4 is 2 times 2. If you don't bring the 2, it's not a big deal, but it is useful to understand that it is part of the greatest common factor. Then I move on to the 3x minus 1 to the 4th, and the cubed is the highest power. So I'm factoring out my greatest common factor, which is 6 times 2x plus 4 squared times 3x minus 1 cubed, and then I open my parentheses, and I took the 3 away, and I took all of the 2x plus 4 squareds away, and I took the 2 away, but I only took 3 of the 3x minus 1s away. So I have 1 3x minus 1 left. Plus, over here, I took 1 of the 2x plus 4s away. Oops. So that means I have 1 left. So I'm like 2x plus 4. From the 4, I only took a 2 away. And then I took everything else away. Okay, are there any questions about how I just factored out the greatest common factor? Okay, so then in here, we need to expand and combine like terms. Okay, so again, privately in the chat, tell me what's going to be left over in those parentheses once you have expanded and combined like terms. Good job, Luca. Yeah, good job, everyone. Yes. So the answer is 7x plus 7. So now I want to set f prime equal to 0, which means I'm setting each of my factors equal to 0. So f prime equals to 0. So I'm setting 2x plus 4 equal to 0. Remember, the powers don't matter. 3x minus 1 equal to 0. And 7x plus 7 equal to 0. To give me 3 values. And so those are the 3 values where the tangent line is horizontal. For my final answer. All right, guys. Any questions about this problem?
But -1 plus 6, it's not 7, right?
-1 plus, it's +8.
Oh, plus, my God, okay. Yeah.
Yeah, so like, well, this will be 3x minus 1 plus 4x plus 8. I'm sorry. Yeah, plus 4x plus 8. Okay, any other questions? In that case, we are going to end there today.